Alright, in this presentation we are going to try to bring a PCM, ECU, ECM, whatever you want to call it, the engine control module, powertrain control module, engine control unit, the computer that does engine management, on a 2005 Hyundai Sonata. So what we're doing today is we are going to attempt the clone of the original PCM vehicle specific data into the salvage module, into the salvage PCM, and that should restore the vehicle to functionality. Literally, we're going to clone the information from the dead module into the salvage unit. So what I want to do first is show you the original PCM, and that is here. Oop. And I've already released the tabs, which is how this thing is held in place in its container. And you can tell it's the original because it says original on it. So take it out of the container, and if you look at it, zoom in here so you can see it a little bit better. You can see, at least I think you can see, that there is some corrosion around some of the connections on, this is the processor here, and that has got lots and lots of pins, and these are drivers over here, probably injector drivers or whatever other things this module is responsible for managing. And I'm not sure what that chip is. Could be an external RAM chip, I'm not sure. But there's and you'll see it when I show you the difference between this module and the salvage unit module, that this got moist somehow. And I'm not sure how. I don't know if it was just because of humidity in the environment in which the vehicle existed, or I don't know. I don't know how it got wet or not. It doesn't look like it was wet. I've seen wet modules before, and this is not one that got wet. But it's had enough humidity, and with that humidity and being electronically active, you can get corrosion, and that's exactly what we see here. But on this side of the module, let's zoom out here, there are no 8-pin parts. But on the other side, and this is something I want to emphasize to people, you want to, when you're doing examination for the location of the if the module has an EEPROM to which you can attach, you want to look at both sides of the board, because with surface mount technology, you can put parts on both sides of the board, and we have had customers that have sent us pictures of only one side of the board, and then later on they will respond and say, oh, I flipped it over and the EEPROM was on the other side. So yeah, you want to look at both sides of the board. Okay, so this side of the board doesn't appear to have any corrosion to speak of. Okay, but you'll see that it has a whole bunch of surface mount components and other ICs, and we were looking at part numbers, and the only part that seemed to be possibly an EEPROM was this guy. Let me get my pointer pencil here. This guy down here. Okay. And let me zoom in so that you can see the number on it. Okay, we're zoomed in, and as I said, if you look right here, my pointer pencil pointing at it, right there, the number on the part is A04. And you'll see it's got a dimple, which indicates pin 1. But you'll notice there's no manufacturer. Don't know who makes that part. Is it Microchip? Is it Fairchild? Is it who? ST? Don't know. So one of the things about our automotive kits and our product in general is that over the years we have collected a lot of part number fragments that have been used because these parts are so tiny. The manufacturer, they won't print, one, they won't print their logo on it sometimes, you don't know who made it. Two, they won't print the whole part number, so you don't know actually what it is. So, you know, given that, and that was one of the reasons that we decided to basically get this here, is so that we could determine whether or not this was a module which could be cloned. And the A04 was the only part that seemed to have a number that might come close to being a part number fragment for an EEPROM. So we went ahead and checked on our software, and let me show you what we found. Okay, I've got the programmer already attached to the computer, so if you've watched any of our videos, you've seen this countless times. But here's the device selection table, and down at the bottom, down here, it says enter device type. Okay, well, there are lots of pages of devices because our product goes back. It supports parts from the late 1970s up to the most current technology. But A04 wasn't something, because the families of EEPROMs, microwire, SPI bus, and I2C bus are the typical families that you find in the vehicles. And those are prefix of a 93 family, which if you watch our other videos, 93C56 is a common part. If you do airbags or some of the European modules, a 95 family, like a 95040 or 95080. And then you've got the 24 series. Okay, well, rather than try to look through all the part numbers, we just thought, let's just do a search. And so we put in A04 and press enter, let the system search. And voila, we have encountered an A04 in the past. So set the programmer up. It says which adapter to use for in-circuit work, how to set that adapter up, and all of those things which our other videos have covered, so I'm not going to do that. Okay, so for this particular module, things were looking pretty good. So let's move on from here and hook up the programmer to the part. Okay, one thing about this module, which may have contributed to its failure due to corrosion, was the fact that there was no humidity sealant on this module, which is kind of unusual for vehicle modules. Usually the manufacturer, and I will guarantee you Hyundai or Hyundai, or however you choose to pronounce the term, the word, didn't make this module. It was made by somebody else, because car manufacturers don't make modules. Anyway, on the module itself it says, what is this? Kefico? Kefico, so I guess that's who made it. Well, they should have sprayed, but there is a Hyundai logo on here. They should have sprayed humidity sealant on this, and it probably would have kept it from failing. But anyway, we have the clip on the A04 part, and it's selected in our software. So what we're going to do now, and just so that I mean, I don't want to rehash a bunch of stuff we already covered in some of our other videos, but you notice when we showed the picture of the A04, the EEPROM part, it had a dimple on the lower left-hand pin of the part. That's pin number 1, and then the clip that is attached, there's a red dot which indicates pin 1. That's how you know how to orient the clip on the part. So we attached the clip to the part. Didn't need to clean the part. We just stuck it right on there. And now we're going to switch over to the computer. And we're going to go to the buffer editor, which you've seen us do this in the past if you've watched our other videos. And we're going to press Q for quick view to see if we have any data. Okay, and yes, we have data. And if you look at the data in the upper right hand corner, first right here, from here, this is a VIN is 17 digits. Okay, so we have 1 through 16, and then the last one is 17. And the person who sent this to us wrote the VIN down on the paper that was included with it, and that's the VIN. It matches. Okay, but if you look, you go, well, it doesn't look like there's much in there. How could that information contain everything that's needed in order to identify this module? Other characteristics that might be required for functioning in the vehicle. Well, if you look up here, okay, it says device size. Okay, that's the storage capacity of the part, 0 to 1 FF. All right. Well, the way that our software works, this page of information is 256 bytes. So it just goes 0 to here's F0 here, and then it goes over to here, which would be FF, and you see that there is and AB there. But there's more to this. This is 1 FF is 512 bytes. So if we do page down or whatever, we can see the rest of it. But in order to do the page down, we're going to have to read it into the buffer. And we're going to do that as we've shown in the past with Command G. So let's do Command G. There's the data, part and buffer match. And what Command G does, it reads the data from the part, reads it into the system buffer. Okay, that's the area that we use to hold the data from parts for both reading and programming and working on the data if you choose to do that. So we got the data in the system buffer now, but let's go down. We're just use the down arrow key and scroll down. And you can see that in the second half of this part, there's significantly more data. Okay, so this is additional information that the PCM requires and was stored. This can be anything from engine parameters to key information, meaning if you have a transponder-based system and the key information from your fob has to match key information in the immobilizer, which then has to match key information in the ECU. This is where that will be stored usually. And I'll show you something else. If you go down here, you'll see this is 1F0 and over here is 1FF. So this is the end. Okay, if we go past this, all right, we don't restrict you on the use of our buffer. If you wanted to do other things, more advanced things, you can. You see this address over here, 200. That would be if this chip, if you wanted to read like 2 chips into the buffer or something like that, that's where the next chip would start. Okay, but anyway, we're just doing a clone in this one, this demonstration. So here's the VIN, and what do we do now? We got that data in the buffer. Okay, well, to do a clone, all we got to do is move the clip over to the salvage module and program it. So let me get that hooked up and we'll do it. Okay, this is the salvage module. See, it's got this tag here, which came from Seymour Auto Wrecking. So let's take it out of the case. And if you look, let me pause and zoom in so you can see the difference here. Okay, I hope you can tell the difference between the original module, original PCM, and this one. But if you look at the the circuit assembly, there's no corrosion on this one. This is nice and crisp and clean. So this module was not exposed to any kind of moisture. So we should have a pretty good opportunity for success. So let me hook the clip onto the EEPROM in this module, and we'll program it. Okay, I have the clip on the EEPROM on the salvage module, and one of the things that you want to do, okay, I mean, I've got the data from the original one in the system buffer, but how do I know that my clip is actually aligned and connecting to this part? Okay, well, I'm going to go back to the computer screen. I'm going to show you. Okay, there's the data from the original PCM, but we have a function called Quick View, and what Quick View does is it will let you read data from the part, and it only reads the first 256 bytes into the buffer, or onto the screen, but not into the buffer. So it will not disturb data that's already there. And the Quick View command is invoked by pressing the Q key. Okay, so I'm going to press the Q key and watch what happens. Nope, keyboard, Q. Okay, you'll notice that the VIN is different, and the numbers that were down here are also different. Okay, so now I know that I'm hooked up to hooked correctly up to this part. So when I go ahead and attempt to program, then I should be successful. Okay, so the Quick View command is really a convenient way to determine, and I pointed this out in our other videos, that you're hooked to the part. Okay, you read the data from your original module, it's in the buffer, and you put the clip or the AccuTouch probe, whatever your connection option is, onto your target, and want to be sure you're connected, so you hit Q, and you'll notice up here it says device contents. It doesn't say the normal buffer end message, which we normally display there. So it'll say device contents. That's how you know that what you're looking at. Okay, well, we're back to the buffer now. That's the data from the original PCM. So in order to make the salvage PCM an exact clone of the original PCM, all we have to do is program device from buffer, and that, if you watched our other videos, is invoked with command number 2, which you can do either from the main command list or from the buffer editor. And I'm just going to do it from the buffer editor here. So I'm going to say 2, and it says program from buffer start, address 0, and I'm going to say yes, and we're going to program. Programming complete, data verification is correct. So we have just cloned the original PCM into the salvage unit. All right, now basically we're done. So you would disconnect the clip and put it back in the box, and I'm telling you, I might want to put some RTV around that seal so when it's reinstalled in the vehicle it doesn't get wet. Put it in the car, and the car should start and everything should be fine. That's the way it is supposed to work. Now, I have an opportunity here to show another procedure that you can do since we've got this this module. And what I'm going to do is I'm going to show you how, if you only had one module, you could do just a VIN edit of that module. Okay, clearly we had the original module and we had a salvage unit, so doing the clone, this is the easiest, fastest way to basically get your job done. But if you only had one module and all you wanted to do was edit the VIN, and assuming that the other data that the vehicle that was stored in the EEPROM would still allow the vehicle to start and run, you could do just a VIN edit. So what I'm going to do is show you how to do a VIN edit. Okay, what I'm going to show you for the remainder of this video is we're going to do a VIN edit. But we're going to do a VIN edit using some different commands in the software. And in the past, I've done a VIN edit using the write command, basically, where I went into the buffer and changed the VIN, and then used the write command to write the changed data into the EEPROM. But in this example, I'm going to show you something else that you can do. If one of the things that our product lets you do is very detailed byte-specific work on EEPROM data. Most other tools have no capability like this. So we're going to use a couple of different functions. One is called single byte program, where you can literally go in and program 1 byte at a time into the memory part. And the other one I'm going to show you is what's called the inspect command. So in order to proceed, let me switch over to the computer. And this is have not read the data from the module, and this is the data coming out of the module is the salvage data. Okay, so to read that data, I'm going to press V, and you'll see there's the data from the salvage module. And what we want to do is we want to edit the VIN so that it matches the original module. Okay, now the VIN from the original module is different in several places, and in order for us to modify those places, let's find out exactly where they are. Okay, so the first location, which is different, we're going to use the modify command. And we're going to say modify 0, which is not a spot we're going to modify, and we're going to go into set this so that it's in ASCII, so it'll be easy for us to choose the right character. So we'll press the tab key, change over to ASCII, and the first difference is right after this S. Okay, the salvage module is S2, but the original module is an S4. Okay, so I'm going to position the cursor over the 2. I'm going to press 4, and we're going to change it. And then we're going to move to the VIN itself, which is, this one is 161379. Okay, so the 1 doesn't have to change, but the 7 has to change to 6, then 1, then 3, then 7, then 9. Okay, so now what we've done is we've modified the VIN at only the digits. We didn't modify the entire VIN, because since it's a Hyundai Sonata, a lot of the data in the VIN is going to be the same. Only characters specific to the vehicle itself will be different. Okay, so let me show you something here. We've modified what you see on the screen now is in the buffer, but it's not been programmed into the part. Okay. So if I say quick view, I'll press Q for quick view. You can see that that's the data that's still in the part, okay? Because up here it says device contents, all right? So and you can see that we have the S2 and the 179086, which is from the salvage module. When I press escape or any key to change it back, you'll see them change back. Watch. Okay, so now that's what's in the buffer. Okay, now I'm going to show you something else. I'm going to show you this. I talked about the inspect command. Okay, the inspect command works similarly to quick view, where I can say inspect, press I, and it says inspect device contents 0, and if I press enter, okay, you can see there's the data. So I just inspected the first 256 bytes of that part, and it looks just like the quick view command, except you have to enter more data. You have to say inspect, and you have to press 0, then you have to press enter. Okay, so there's more to it. The other reason we have the inspect command is the inspect command has another option, and that is inspect. Okay, we're going to say inspect. We're going to say 0, which is the first address in the part, and then we're going to say give it another 0, which is the first address in the buffer. Okay, now with those two parameters entered, when we press the enter key, you'll see that any changes, any differences are shown on the screen in reverse video. Okay, so there's the two that we changed, and these are the changes that are differences in the part. Okay, the part has a 2, and these are the bytes that are different. Okay, so you can see that the inspect command is handy because it gives you the option of doing an actual physical presentation of the differences in the part. Okay, so you tell it what you want to expect in the buffer and what you want to inspect in the part, where you want to start in the buffer, where you want to start in the part, and it will do that, and it will show you what's different. Okay, I'm going to press a key, and those will go disappear, and we're back in the buffer at this point. Okay, so now the next thing that we want to do is we want to modify, basically put those changes which we made in the buffer into the part. Okay, now we're going to do that with another command, and that command is single byte program. Okay, and the single byte program command is invoked by pressing E, and you'll see it says single byte program, and it wants to, the next thing it needs to know is where in the buffer you want to point, what byte you want to point at to program that specific byte into the part. Okay, so I'm going to say, I'm going to go to 0. We're going to say 0. I'm not going to program 0. And then I'm going to press enter. Okay, and what you'll see is in the upper left hand corner, you'll see we have a blinking underline type cursor here under the very first byte. And where's the byte that we want to change? Okay, the byte that we want to change is right here. We want to change that byte. Okay, so now we're going to move that underline cursor over until we're pointing at that particular byte. Okay, that's the 4 that we want to change. Now to change that, all right, what we're going to do is we're going to press the insert key, and what you'll see happen is the 4 changes to reverse video. That means that one byte, when we pressed insert, programmed only that byte into the part, nothing else. Okay, and we can show that like this. All right, I'm going to press escape, and I'm going to use the inspect command again. I0 space 0 enter, and you'll see that where we used to have an indicator that showed the bytes in the buffer or the byte in the buffer and the byte in the part were different, now they're the same. All right, so with the single byte program command, I was able to change just one byte. Now I'm going to go ahead and change the remaining bytes in the VIN so that they match the module from the original vehicle. Okay, and in order to do that, we're going to exit the inspect command. We're going to go back to single byte program, E, and we're going to go, I'll just use 0 again so you can see it. And then we're going to move the cursor over to the 3.6, okay, which is the next character that we want to change in the VIN. Remember, the 1 didn't need to change. So in order to program that byte, we press insert, and then we press insert again, because it'll move over to the right every time you program an individual byte. So we just program 2 bytes, 3 bytes, 4 bytes, 5 bytes, and now we're done. Okay, we've just used the single byte program command to program 5 bytes, which were the remaining 5 characters of the VIN, into the part. All right, so now we've completed the VIN edit. We can get out of this. All right, press escape. But now let's do the inspect command again. Inspect 0 space 0. All right, so we're going to look at compare address 0 in the buffer to address 0 in the part. And when we press it, you'll notice that there are no reverse characters indicating any differences. So we have now done a VIN edit only on the bytes that we wanted to change in the VIN. We didn't change the whole VIN. We could have changed the whole VIN. But the reason I did it this way is so that you could see another couple of commands that we have available to you when you're doing detailed work on individual bytes of data in a part. So we've now done the VIN edit for this particular exercise. Okay, well, that pretty much wraps up what I wanted to show you with this demonstration. And as always, we hope you found this information useful, and we are glad that you took the time to watch our video, watch our presentation. If you like this kind of content, we'd appreciate it if you would click the like button, because that helps more people find out about us on YouTube. And if you would choose to be notified from about other videos that we produce, you can subscribe. And as always, lastly, if you would like more information about our products, they are available on our website. And once again, the website is arlabs.com. And we very much appreciate the time that you invested in watching.